Aloha class, here we go. Arc length, BC topic. Homie Holmes, Mr. Arliss, you thought I didn't see you hide him over there by the Kleenex, but I did. Homie's got a little tear. He's got a boo-boo. All right, arc length. Okay, you've been doing arc length actually from your trig days, right? And the arc length that we're doing here is we're associating arc length with certain curves. Okay, and to just do a brief like introduction of what we're doing here is, let's say we have our curve right here in red, right? And I wanted to find out the length of that. One way we could do it back in the day is we could make these little line segments, right? We have our tangent lines as we go there, right, class? And if you look at this, I'm not going to get crazy and do the whole derivation of how we come up with this formula. Come in someday if you want to see it, and I'll show it to you. But we have a change in our x, right, class? And we have a change in our y, okay? Thus bringing up the idea of calculus, right? And then what we do is, hopefully you have an idea already, right? If we've been in calc for an entire, some of us, a year and a half, is we have these lengths right here, okay? And we add those guys together. It gives me an approximation of what's going on. How could I get a better approximation, right, class? We shorten those lines. We shorten those lengths. And we keep on shortening those lengths, right? Maybe between here and here, right? And then there and there. And we keep on shortening that until the distance between those lines is nothing. Right, class? What is that the idea of? Well, we all know that that is the idea of a limit. And thus, we could derive a formula that would give us the arc length along any such curve. Booyah! There it is, right? How sweet is that? And we actually could have derived it. It's actually derived from the distance formula. Remember, the distance formula is the square root, your change in your x's, which I just talked about, your change in your y's. We have an infinite amount of those guys, thus it brings up that integral, right? An infinite amount of them, right? The change of them is a change in x, and then it's the square root, and there's a way to get that. You know what, though? Me, you, we're just going to believe it. You want to see it? Come in someday, though. I would be happy to show you. All right, we're just going to get after it because this is kind of just the nuts and bolts of BC, okay? Just some additional topics and formulas we're going to have to be able to use, all right? But we got Holmes going along this path right here. Get there, homie, get there. Homie is slow, yo. All right, but let's say he's walking around this path, and the path is defined by that particular function right there. And he's going from 0 to pi over 4, okay? Miles. At the end of my stroll, how far have I traveled? Give an exact and approximate answer. And yes, I only traveled along paths that can be mathematically expressed. All right, here we go. So it is as okay as this. Arc length, right? We like to use this. How about it? Sweetness. My pen ran out. Should I reboot this bad boy or use my pen? I got my pen right here. Let's see how it looks. Let's just see if I can maybe get this guy. Let's see how it's working today. Penny pen pens. There it is. All right, let's go. Fancy L. L is equal to, right? It's the integral. This is going to go from 0 to pi over 4 of the square root of 1 plus my derivative squared dx. Well, what the heck is my derivative squared? Well, guess what? All I have to do is do a little side work. Okay, and I do a little y prime. And, ooh, that's a natural log, right? The derivative of a natural log is 1 over. Don't you dare touch that inside, right, class? But now I have to multiply by the derivative of that inside. And the derivative of secant is, ooh, secant x, tangent x. Oh, sweet, sweet. And so my answer is just tangent x. How about that? Well, that's interesting. Now, this problem said I have to give an exact answer, all right? So let's check this bad boy out. Tangent squared x. Well, what the heck is, how am I supposed to take the antiderivative of all that stuff, Mr. Tanaka? Well, we go 0 pi over 4. Hopefully you notice something. Hopefully you notice that 1 plus tangent squared x is a Pythagorean identity. Pythags, right? And that would give me secant squared x. If you don't believe me, go back to your pre-calc notes, class. Now, if I take the square root of that, that'd be 0 to pi over 4 of secant x dx. Now, believe it or not, you could do this bad boy by hand if you memorize those tougher antiderivatives back when we were doing AB topics. Now, I wouldn't expect you to remember them because I can't even always remember them all. Okay, so this would be it's the natural log of the absolute value. Remember, these were all on our notes back in the day. And I said, yes, this would not be something that you would be required to know on the actual AP exam. But we could do that from 0 to pi over 4. So guess what you get to do in my class? You could just go back to this original problem, put that bad boy right there, sling, 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 into your calculator, and I'll put my answer here in blue, and then I'm going to reset this bad boy, and if I put that into my calculator, I get 0.881 miles. That's how far Holmes went. If you did this, plug in your pi over 4 and your 0, you would get the natural log of the absolute value of the square root of 2 plus 1. And you should check that because I'm sure you should refresh and make sure you're good with your trig values. But once again, I would not expect you to have that antiderivative memorized. So if this happened on one of our quizzes or tests, booyah, you just got to be able to get to that step. Put that bad boy, math 9, that bad boy, and then you'll be good to go. See you soon. All right, here we go. Example 2. Hopefully my new screen here is good to go. We'll check it out, all right? Example 2, find the exact length if that is my curve and I travel from 0 to 1. Okay, that's just, hey, arc length is equal to, right, the integral, this time from 0 to 1. The square root of 1 plus my derivative squared dx. How about it, class? That's it. Not bad, right? Okay, I just have to be able to find a derivative. So I got to do a little bit of side work. And I mean, this thing's just so awesome today. I mean, it's just like, it just keeps on running for so long. Awesome. All right, here we go. Sorry, class. We got to try this guy one more time. All right. So let's go. We got to do a little side work. We're going to do a little y prime. If I drop that, I'm going to drop the 3 over 2. And I already have a 4 square root 2 over 3 out there. It's going to be x to the, I got to subtract 1, so it's 1/2, and then it'd be 0. So if I spling, 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 I get a y prime, which is equal to 2 square root 2 x to the 1/2, okay? So I'm going to take that bad boy and I'm going to plug it in here, square root of 2 x to the 1/2. I can definitely simplify that. Sorry, you guys, again, it's having to use this pen. Okay, square root of 1 plus, let's see what we get there. We get 4, 2, that'd be 8x. Oh, sweet, it's kind of nice. So my guess is, hey, this would probably be a non-calculator question. Okay. So if it's a non-calculator question, maybe I need to go 0 to 1, 1 plus 8x to the 1/2. Now, hopefully, if we're in BC, we can maybe do this without doing u sub. But, if I did make my my u, it'd be the inside, which would be 1 plus 8x. Derivative of u is 8, right? So if the derivative is 8, then that means if I did my little u sub, I'd have a 1/8 in there, right? So let's see if we can do this by hand without showing the work. So I'd have a 1/8, right? Don't you dare touch that u or the inside, so you're going to have that. Okay, right? And then what do we do to this? Well, we add 1 to the exponent, so that'd be 3/2. But then remember, we have to divide by 3/2 or multiply by the reciprocal. How about that? I did it all at once, and we're going to do that from 0 to 1. And let's simplify a little bit. My constant out there in the front, what's that give me? That gives me a 1 over 12. Right, class? I'm going to check my notes, make sure that's good to go. Yep, for sure. And then I get a 1 plus 8x to the 3/2. Okay, let's do some work. Oops, 0 to 1. Oh, I'm going to bring it down here. All right, let's check this bad boy out. Let's plug a 1 in there. 1/12, right? It's going to be on the outside. I'm going to actually factor that out of all of it. Okay, class? If I put a 1 in there, I get a 9er, right? A 9, I do the square root, which is 3. That'd be 27. Okay, right? That's not good. You're coming in for class. I put a 0 in there, I get a 1, so that's uno, ichi, 1. Okay, do that work, we get a little 26 over 12. Oh, snap, that bad boy can reduce to be 13 over 6. Not bad, right, class? If it's a non-calculator, you'd be able to have to do stuff like that, okay? We did example 1, you'd be able to use a calculator. Example 2, no. All right, here we go. Let's roll. Ooh, example 3 is so fun. Come on. please work. Magical pen. All right, magical pen, let's roll. Calculator permitted, but it says it's highly discouraged until absolutely necessary. Why? Why would they say that? Well, let's maybe find out. All right, find the length of this curve right here. Oh, that shouldn't be too bad on that interval. That shouldn't be too bad. What's the problem, Liz? What are you talking about? How can we cleverly circumvent it? What the what? What is that thing talk about? Let's just do some work. Okay, arc length is equal to the integral. Ooh, it almost went out on me, class. Negative 8 to 8. Maybe I'm writing too fast, right? Times the square root of 1 plus the derivative squared dx. Well, okay, let's find the derivative. That's a sour, right? So we got y equals x to the 1/3. And the derivative of that bad boy would be 1/3 x to the negative 2/3. Okay. So we got a little 1/3 x to the negative 2/3. All right. Let's go ahead and plug that into my calculator. Is it time now? If I plug, oh snap, it gives me error. Oh, what the what? I must have to cleverly circumvent that. Holmes? Does Holmes have an idea? He says, look at the graph. Okay, he says, look at the graph. All right, let's look at the graph of this bad boy. Hopefully we know that looks like that. And if I was really to zoom in like crazy, there ends up being a vitae, right? A vertical tangent at x is equal 0. Well, that must be y. Oh, and then look, negative 8. Oh, I can't have a 0 in there. Oh, so what am I going to do? How am I supposed to do this problem? Well, all right. What you could do is say, hey, that graph is practically the same exact thing as its inverse. Well, inverse, what are you talking about, Mr. Tanaka? In terms of inverses? Well, I'm sure everybody remembers that if I wanted to find the inverse, we flip-flop those guys. You remember doing that? And what do? We solve. Right? And if I did that, I would get x to the 3rd. Well, what does x to the 3rd look like, class? It looks like that. And guess what? There is not a vertical tangent on that. Oh, so I could use that information? You actually could, because it's the same amount. So, but now the one thing we have to understand here is that if I go here, I'm trying to find this length from, oh, snap, from negative 8. Negative 8, what would that be? That would be negative 8 comma negative 2. All the way to what? 8 comma 2. Oh, so I want to find this entire length right here. Well, guess what? I just have to find its equivalent on my blue graph, which would be what? From here, what would that be? Well, that would be the inverse, right? We flip those points, right, class? That's what happens on inverses. So I need to find that. Oh, okay. And guess what? It will give you the same exact arc length. Ah, that was cleverly circumvented. All right, here we go. So we go, arc length is equal to the integral of 1 plus. Okay, I got to do a little side work again because my derivative is going to be different because that's the function of, oh, I can do that. That's just a little 3x squared. So we're going to put a little 3x squared into that bad boy, right, class? Ooh, negative 8 to 8. No. Right? This is x's, so it's got to be my x's, which would be negative 2 to 2. All right, let's simplify this and see if I would need a calculator. Okay, booyah. 1 plus 9x to the 4th. Okay, can't do that antiderivative, so now you're allowed to use a calculator. Now, guess what? If you use your calculator, it should work out in that one. What did I get here as an answer? I got an answer of 17.261. Now, you know what's interesting? What a lot of people would say maybe about this one is maybe I could go from 0 to 8, right? Maybe you go from here to here and just double it, right? Because there's some symmetry going on. And sometimes you are able to do that. But for this particular problem, our calculator still can't handle that, okay? Like, for example, this problem here, you could have doubled it and went from 0 to 2, okay, of 1 plus 9x to the 4th. And you would get the same answer. Okay, but it's important to know. Some of you might have been saying that at home. If you said that at home, you did a really beautiful job. But it doesn't work with that for this one. Okay, class? All right. Sounds like I've got a little froggy. stuck in my throat. So let's get a little wah-wah, right? Hopefully at home chilling. Listen to a little Bob, listen to a little Jack. Okay, get a little thirsty thirst. Nothing good like some high quality H2O. All right, here we go. Let's keep going, and the pen is working. Thanks, Holmes. All right, example 4. Nah, you won't need to know something like that on your AP exam. So I'm just going to give you what you need to know. And I know most of my students would appreciate that. I would actually love to teach you some of this other stuff. So you know what? You get bored one day in the morning, come hang out. Me, you, and Holmes will do work. All right, I think you're going to like this, all right? This is X in terms of Y. So some of you are thinking, oh, no, we got to like solve for all crazy stuff. No, you don't, because if it's an X, as long as it's a Y, you can still do it. Have no idea what that was, okay? All right, but here we go. We can just get after it. As long as if my function's in terms of all Y's, that's in terms of all Y's, all right? So we're just 1 to 4 times the square root, 1 plus that guy squared. But what is it? It's dy this time, right? Everything has to be in Y's. So we do a little side work. X prime is equal to, what is that? We're going to drop that. Oh, sweet. It just turns into a 1. Don't you dare touch it inside home. And then you subtract it. There you go. So I'm a little like that, right? Ooh, to the 1/2. Okay, I'm going to square that. That kind of works out really nicely, huh, class? And you get 1 plus, is that, no way. That just ends up being that, right? dy. Well, okay. So that ends up being this guy, which that's just going to be y to the 1/2 dy, which, okay, let's just add 1 to that. So it'd be y to the 3/2. I have to divide by 3/2 or 2/3 from 0 to 1 to 4. And then what do we get? We get a little 2/3, right? We should always factor out that constant. Let's put a 4 in there. 4 to the 2/3, 2, that'd be 8. Put a 1 minus 1. What do we get there? A 7. I feel like that's not the answer I got when I looked at my notes earlier. It is! Sweet! And that would be a non-calculator, right, class? So make sure you can do that without a calculator if we do it on our notes without a calculator, okay? All right, you know what? I mean, hit pause. Make sure you're good to go. I'm going to give you the answer to this bad boy. I am very confident you'll be able to get this. Actually, here, I'll do this. Hit pause. I'm going to put your answer here. Your arc length is equal to, snappity snap, the integral from 1 to 2, right? We can do it because it's all in terms of y's. It's written a little bit differently, so see if you can get it on your own. And if you do it correctly, you get 1 plus. Right? It's just taking a derivative of that. That's from the first half of calc. That'd be 1/2 y squared. And what do we get here? Minus 1/2 y to the negative 2. Believe it or not, this is one that you should be able to do without a calculator. So you may want to challenge yourself. But you get in, if you were allowed to use a calculator, you could just plug that bad boy in. And there you go. All right? That's it, class. Not bad, right? Little arc length. Okay, guaranteed to be a multiple choice question on your AP exam. Okay, let's keep rolling. I think we have one more we want to touch here, okay? So there, let's get this guy up. Kind of a word problem. You'd have no problems with it, so try it on your own. This would be a calculatora. All right, so we have our function here, right? This is what some of our fancy, I love these roofs. My sister's got a crib down in Chi-Town, and she's got that cool roof. I love it. Absolutely love what it does. Okay, we have 28 inches of panel. This is where they give you some information to try to confuse you, right? It's still just 0 to 28, right, class? So I'm actually just trying to find the length of that curve, right? So I just use my little arc length formula, right? I'm just going to go 0 to 28. That's all this bad boy is, class. And I guess the toughest part here would be 1 plus what the heck is the derivative? It's got to be all in terms of x's, which we're good to go. So we do a little side work. It works. Right, we go a little y prime. Derivative of sine is cosine. Don't you dare touch that inside. Take the derivative of that inside, which is pi over 7. Right, and then we just plug that bad boy in here. Pi over 7 cosine of pi over 7 x. Definitely a calculator. Plug that bad boy in, and I got an answer of 29.361 And I think they're talking about inches. So there we go. That's it of arc length. All right. Now I got your notes right here. All right. And I would like for you at home to do your worksheet on arc length in its entirety. You know what? Let's save the 7 and 8 for class, which are the AP questions. All right. We'll do that as a little challenge. No getting ahead. So I want you to do 1 through 6 arc length. Okay. And then you're also going to watch the L-hop video, right? Do it, Holmes. L-hop video, okay, on L'Hopital's rule. And listen up. I'm not doing the notes on these. I'm using an L-hop video that I used for AB that I want the BC students to watch too. So if you go to your, I got it here because I wanted to show you. Where's my L-hop? L-hop, right? Homie, do it. L-hop. All right. So we will. Don't worry about example 1. Don't worry about example 2 or C. I want you to do example 2, A, B, C. Should be able to handle that there. Look at L-hop. L-hop. Oh, I think I might do it, right? Should I maybe grow it out? Do that? Maybe Holmes? Man, I would look. Would that be good? Would that be a good look? I don't know. L-hop. Okay, you're going to see the video. Do example 3, please. Do example 4, 5, and that's it. Okay, that's your homework for our next class, all right? And then we're going to work on some of the tougher ones when we're in class. Aloha. Hope you've enjoyed the video. I will see you next class.